All right, how's it going, everybody? We are live, and today we're going to be working on the compiler some more. We'll be continuing some of the work that we did earlier on for composable function interfaces. So this is basically where Kotlin has these new types of interfaces in 1.4, where you can have a fun interface, and they have a single abstract method. And so far, we haven't really provided support for this if the single abstract method is a composable function. Due to various things, it ends up kind of breaking in this case. So we explored fixing this, and the kind of end result of that stream, or it might have been multiple streams, I don't remember. The kind of end result was that we figured out that we basically don't have access to the proper this parameter that the the object that implements that interface would have at the time that the compose compiler plugin is doing its lowering. And that normally wouldn't be a problem, except for composable functions need to create a lambda which can then essentially recall itself. And so the only way to do that is to get access to the object. And so we kind of figured out that there wasn't a good way to do this without basically pulling out the SAM conversion, or like the lowering of these function interfaces, without essentially duplicating that in the compose compiler plugin. And so we talked about this a bit internally, and I think what we're going to do is in the near term, we're actually going to just do that. We're going to pull out the lowering code. Hi, Nico. Yeah, good to see you as well. Thanks for, appreciate the congrats. So it sounds kind of not great to pull this lowering out into our compiler code, but I think that we can do so in a reasonable way. It's only the entire lowering in Kotlin is about 500 lines of code, and it's actually handling a number of other things that we wouldn't have to handle. So I think it can be quite a bit shorter than that. And what I'd like to do is try to factor it in a way where down the road we can create a reusable function in Kotlin that does a lot of the legwork, and make that public and make it so that we can use it in our lowerings, and then just kind of be done with it. So, or at least like ease the maintenance burden of that. So like to kind of give you a bit of an idea of what we're talking about here. Let's say I have a fun interface, let's just call it foo because I'm lazy. So this has a method in it that's composable. And the idea is that if we had some composable that accepted one of these, then if we called that composable, we would be able to sort of leverage this lambda syntax being converted into one of those interfaces. So essentially what this means is that, this works. And with this, so we're using this trailing lambda syntax on A, even though A doesn't accept a lambda, it accepts a foo, because foo is a function interface. And so essentially what we want to compile this down to is something that looks a little bit like this. This was lowercase. And so this is what Kotlin was kind of already doing, was basically converting it into something that kind of looked like this. And we're just going to do that ahead of time. We're doing it in our lowering, and then we'll let Kotlin do the rest, because both of the, like, semantically these are equivalent code paths, but or like basically it's equivalent code. This is just syntactic sugar, and we're going to do that desugaring ourselves instead of Kotlin doing it, and hopefully that's not too bad. So that is what we're going to do today. Let me know if any of you have any questions. So let's see what we have here. I actually need to, we go back to, this was our work in progress CL. What I'm going to do is I'm going to pull that down. Actually, okay. All right, so I'm just pulling down that progress from the other day. And in here, we should have let's see. Okay. So let's go ahead and see. We had written a couple of tests to work with this. Let's check to see if they fail. I think this one ought to fail. Unless what I did, hey Marcel. Marcel says, looking forward to today. Any new leads for the roadblocks from last time? Are you asking like the roadblock that we ran into at the last stream? Is there any way for us to fix that? Because essentially what we ended up deciding was that we're just going to pull into our code base some of the lowering that happens for function interfaces, and it'll be duplicated for us and Kotlin, unfortunately. And then we'll try and work with JetBrains to reduce the amount of duplication over time. Okay, so this test succeeded, and I think that might have been because we had, what did we do? Actually, what I'm gonna do here is I'm gonna pull all of these changes into stage changes so I can see just like the diff of what we added versus what we didn't. So this was new code that we added. And I think what we ended up saying, yeah. So we said if it's the same conversion, then never go down this restartable composable function path, which that ends up removing the need for us to have this parameter. But that doesn't seem like an acceptable compromise to us. So we're gonna go back to allowing that code path. We want the function composable functions on a function interface. We want them to be able to be restartable, and in order to do that, we need to go down this code path. Marcel says, I see that's due to the fact that the compiler plugin is invoked before the main lowering. Yeah, so what happens in the compiler is there's this PSI to IR phase, which takes the kind of initial result from the front end of like all the type analysis and things like that happens on the source code, and then converts, which we'll call PSI, and then it converts that to IR, and then that tree of IR is what our plugin operates on, and then all of the lowerings that would have happened otherwise happen on our lowering. So you can think of it as like the thing that we transform is the highest level or like the highest level of abstraction type IR, and the lowerings continue to make it more and more primitive. So we're working at a pretty high level of abstraction, and I believe the SAM conversion also happens at a fairly high level. So I don't think that'll cause us any problems to move that out, but we'll have to make sure that it doesn't, because that's one thing to be concerned about. Okay, so now that we changed that, I expect this test to fail. And what we'll need to do eventually is we'll need to update this function, which this creates an end restart group call, but also an update scope, a call to update scope with a lambda, and that lambda is synthesized, and that lambda calls the original function, and that's what we couldn't do. So that's where we'll have to deal with it. Basically, this outer receiver needs to be something in our case, even though this will be null. Yeah, definitely. Marcel says, I suppose that order makes sense in the context of basically adding language features, but it's unfortunate that we're not in more control over it. Anyway, I'll leave you to do the thing. Yeah, I mean, we've talked before, like from our perspective, something that would be really nice would be for us to be able to specify, here's a lowering that our plugin is going to insert, and it depends on lowerings A, B, and C to have already run, or something like that. Somewhat of like a partial ordering of transforms. But I think doing that is sort of, it introduces an unnecessary maintenance burden on Kotlin, because there can be really tricky, you know, kind of, there can be very subtle coupling between different lowerings, and they need to have like a really good or explicit like kind of understanding of the order of the lowerings that they apply. And having us like just insert stuff into the middle could be really problematic for them. Okay, so we saw this exception, which is what we expected. Okay. So, I mean, this is like a reasonable just kind of starting test to see if we're making any progress. But we might want to introduce a few more like simpler tests just to more explicitly assert on the lowerings that we're performing, or on like the SAM conversion thing that we're doing. So let me try and pull up. I think it was function reference lowering that ended up implementing this. Yeah. So they've got this function reference builder. Okay. So here's our top level generation extension. What I might do, like we might want to create a whole separate lowering that just happens before all of the compose ones that we do. I think maybe it makes sense to do it after live literals, but before the lambda memoization. I think that's probably the right place. There is a question. We would need to make sure that the param transformer ends up continuing to kind of work correctly, but I think that we'll be okay there. So let's find out. I'm gonna make, actually I think I'm just gonna start by copying this. So what we'll say here is fun interface lower. We'll call it that. I think what I'm probably gonna end up doing is lowering the well, I'll have to think extra about this, but I was thinking that we would only transform the function interfaces that have a composable primary method, just so that the majority of the function interfaces go through the normal pathway, so that if there is a problem, it at least only affects composable function interfaces. Seems a little bit safer to me. So we'll try that. On interface loading, I think I can get rid of pretty much all of this. I'll rename it to that. And the only reason I copied this file is just so that we can get this abstract compose lowering out of it, and just avoided writing some of that boilerplate. But let's see, I think all of these get rid of. Okay, so then let's add this to the generation extension. And well, that's not what we wanted, but yeah, this will go there, and then we'll want to rename this. All right, I suppose that's a start. I think we can ignore that file for the time being. Let's take a look at what this one does. So pass ignores suspend function reference and function reference uses. See, it's interesting that this ignores suspend functions, and I wonder if that's like, I mean, a lot of the problems that suspend functions have in sort of causing issues in some of these lowerings are the same issues that composable functions have, because we change the number of parameters and things like this. Okay, so this visits a block. So it grabs all the lambda blocks, grabs their function references, and calls the builder. Is it? Like, I think we'll need to do this, but we'll need to add some additional logic probably. So I think that is a start. I'm not sure if we need to do that or not. Like, I guess really it's only a SAM conversion that we care about, and I'm worried that this isn't dealing with that. At least I think that's the case. So we might start off with just looking at this, I think. So let's go ahead and do that. We'll just look at like, so I think we only care about same conversions where it's a function interface that has a primary composable method. So I mean, like, one thing that we could ask, we could see if Kotlin would be willing to just make function reference builder a like public class if they moved it away from the inner class thing. That might be a reasonable thing to do. I'm not really sure. Like, I want to try and keep the structure that they had as much as possible. So what I'm going to try and do, or the structure that I think I want them to have as much as possible. So what I'm going to try and do is turn this into a non-inner public class locally for us and change pretty much nothing or as little as possible. And if that works, then maybe that can be what we ask them to do. So I'm gonna go ahead and create a new file for that, just so that it's like also contained. So let's see what that looks like. So we'll make it just a proper class instead of an inner class. And so it looks like the context is one of the things that it asks for, but it's just using, I see, so it's using state and generate optimized callable reference superclass. This is generation state. Is that public or not? JVM backend context. So that's unfortunate because I mean, I guess it means that well, okay, so we could, this is just for a Boolean. All right, so that's what we'll do is we'll function reference builder. What I'm gonna do is I'm gonna make this a constructor variable. And then that can be passed in on their side because they have a JVM backend context and we don't. But symbols we should have. So let me see. Although these are JVM symbols, so I need to get JVM function class. See, and that's the other thing is that, so they use this SAM super type I wonder, because they like basically they create this function superclass, and then that ends up being a function of the function reference, and then this like, you know, get JVM symbol stuff. I wonder if this could just be the SAM supertype instead. So let's see where they use this. Function reference. So, okay, well that I think would still work fine. What is this? SAM equals hash code. Okay, so what does this do? So that's only when the SAM supertype is non-null. I thought it was nullable. So check not null, SAM supertype. Okay, so we would like change this, I guess. Which I think we could do. We could just ask. What would we want to do? We would just need to make sure that it's not like one of these things. So that it's not a JVM function class or a JVM suspend function class. And I think that that would work. Okay, so let's try and make that change. So I'm just gonna say supertype. I'm gonna rename this to supertype. It's already what? Super method. Oh. So that's a little bit weird. I guess there's a function superclass and a super type. So maybe we need two of them. So let's say that this is, let's, instead of renaming it, let's just create new ones. So function super type. I guess they call it a super class because it's the class, not the, I see. So this would be IR class. And it's non-nullable. Or is it a class symbol? Yeah, it's a class symbol. And so that's that. And I guess we can make that private. That'll be the closest to what we end up with. And then we have a super type, which is the actual IR type. All right. Default type, yeah, okay. Private val sam super type. Oh, and that was already, so we'll just call that super type. And then we can get rid of that here. So we still have some problems here and also here. Function reference receiver field. But at least the declaration parent, no current declaration parent, we can at least pass that in. And so that should be, I'm guessing, let's just go to find that. Okay, that's part of the transformer void with context. All right, so we'll add that as well. IR declaration parent. And I don't think it should be nullable because this happens on initialization, so it would error out if it was null. So that's fine. So I wonder if there's a better way to get this. There might be. We'll check that out, but I think that this could just be super type. Okay, and so then this, I think we can create JVM IR builder. So that's on JVM backend context as well. That's disappointing. I wonder if we need the JVM IR builder versus just an IR builder though. So let me try to remember. Where. So we have an IR plugin context, which implements IR generator context. Which doesn't really give us much. Interesting. I thought that we could do more on this. Our generator was scope. So let me see what this is doing. So this just creates a JVM IR builder. Yeah, I'm not sure that we need a JVM IR builder. So let's see what we can do instead. I think that let's see what is where's our file here? Is this ours? No, it's not ours. I've got too much stuff open now. So this really just needs to create a block. Let's see, temporary. Let's see. We added to the constructor let's see if we added a declaration builder, because that one I know that we can make. So builder.run. So the IR symbols here points to JVM symbols of the JVM IR builder. So this whole like use optimize superclass thing, Like that's something that we're not doing. That's also the whole thing that's needed here. So if we just comment that out, what happens? So I wonder if this is a declaration IR builder. It does not work. Although, but symbols, because we have the IR built-ins, which looks like this is all this really needs. Let's just see if I add that. Our built-ins. Okay. So I can change that and that. Oh, wrong casing, I guess. So we'll have to see if that needs all that. Like, yeah, I guess one of the bigger problems here is that the SAM lowering, it feels very JVM specific, and our plugin doesn't have a JVM backend context. It only has a plugin context, and so it looks like there's a lot of stuff going on here that we're not gonna have access to. And if it's using a JVM backend context to do it, then we won't be able to do that. So that's kind of upsetting. Which symbol is this using? Oh, this is the symbol of the simple function. Like, so I wonder if I give it a generator context and a symbol, and instead pass in a generator context. And then the builder call won't be valid anymore, which was here, but so I can replace that with a declaration IR builder. With the generator context, and then I need a symbol. What symbol did they use? Scope owner symbol. owner symbol. Just be more explicit. Yeah, I think basically I'll have to end up removing a lot of this JVM specific stuff. SAM equals hashcode methods generator. Like, I wonder if this needs JVM context also. Function adapter dot owner. So I didn't even know that we did this. I want to understand more about this because it looks like we're generating an equals and hashcode function that might not be trivial. Okay, so it looks like this doesn't happen. I see. So I suppose if you use the function reference kind of syntax here, this will so I guess the function reference that's created might have a useful equals and hashcode method that's like kind of unique to this, whereas doing this will not. And this is the thing that we care about. Trying to think if I'm not sure I understand where this will come into play for what we're doing. I feel like it will not. So this only happens if we need to generate SAM equals hashcode methods, which is determined where. So if it's a fun interface and it's an adapted reference or not as lambda. Hey Andre, Andre says, just caught up with things you started working on today. Just curious, could this transform be applied to usual function types versus using composable lambda there? Congrats on the promotion, by the way. Thanks. Yeah, I mean, so this is very analogous to what, like basically one of the motivations for the composable lambda was to avoid this issue where we didn't have access to this parameter. I think that I mean, and that's why before we had composable lambda, we actually did all of the lambda conversions ourselves. And one of the big benefits of moving to the composable lambda was that we got to get rid of all that code, which was sort of duplicated code from Kotlin's lambda lowering. So I don't necessarily want to do that. I mean, you could. It's like, it's kind of equivalent to lowering, to just creating lambdas in general. And so you could maybe you could have a different pathway. So like maybe for instance, for JS targets, maybe they don't use composable lambda. They just transform in a way where they have all of the restarting logic in their bodies, and then you generate a lambda class just like you would otherwise. That might be a reasonable thing to do. I'd have to think about like that would, so you would end up removing the like donut hole skipping optimizations that we have for composable lambdas, which would be a pretty significant change in behavior that you may not want. Like I don't think that we would want that long term. So yeah, I don't know. I mean, to answer your question, like basically yes, you could, but I'm not sure that we want to. But then functional interfaces won't have this donut hole optimization either. Yeah, that's correct. A function interface will sort of behave like, you know, like an object with a composable method. So like basically we're saying that lambdas are special, and for the most part I'm okay with that. I'm trying to think. I mean, we could, what would it mean? I guess if we really wanted to get fancy, we could we could basically have our own SAM conversion code. So like basically what we're doing now, but in addition to implementing the function interface, we could also, like, we could write it in a way that it implemented the sort of necessary like tracking to be updatable just like lambdas are, and stable. And then we could we could basically get the donut hole skipping in that way. I mean, that's definitely something we could do long term, but it does sound pretty hairy right now, pretty complicated. So I'm not sure I want to do it. But it is something for us to consider. I'm trying to remember where this generate method gets called and how the plugin context is generated. Yeah, no, it's a good question, and it is very similar. Like basically, it took me a while to realize it, but yeah, the like lambda lowerings can just be considered like a SAM conversion to the function interface, and the problems that we had with lambda lowerings are the exact same problems that I ran into on the last stream, and you know, basically our solution here, at least to start, is the same, where I'm just copying over some of what they're doing. So, you know, it doesn't make me feel great, but that is like kind of what's happening. Okay, so the plugin context gets created. What's the PSI to IR context? Yeah, I mean, so I think what I'm finding is that keeping this function reference builder to be identical to the other one is going to be hard, just because of everything that it's doing. So I wonder if a temporary solution, or I mean, not necessarily temporary, but I wonder if it's a better approach to just try and remove all of the code in here that we don't need and just make it work for our purposes. I guess what I want to understand is, what is this? Is adapted reference. The adaptee call. So I don't think that we'll ever be adapted. Because the adapted call is when it's a this is when we use the : syntax. I'm trying to figure out if we would ever have that case. I don't think that we would. Like, I guess one case that we need to figure out is no, because we've already decided we're not doing that. So I don't think we need to worry about this adapted. And I think because of all of this like this hash code stuff and this optimized superclass thing, I think we might just try and do the slimmed down version of all of this. Basically, I just need that. And let's see, so this isn't needed. Looks like that's not needed. So this we get rid of. And we can get rid of some of this logic, it looks like. So this will always be false. So we can get rid of that. And that'll be false, we get rid of that. And so, I mean, basically function superclass. Like, I think this, the SAM supertype is null. That would have meant so all right, let's just try to build out our example here. So the SAM superclass, if we have our, oh sorry, I'm in the wrong window. So if we've got, let's say we've got a function interface like this, right? Then in this case, SAM supertype is foo. And so that means that function superclass is SAM supertype class or null. SAM supertype dot class, basically. And so that's going to be foo. Then what was the, wait, okay, function superclass. So then supertype is the next thing we're looking at. And so then that's also just foo. So in our case, these should all be the same thing. I mean, this is an IR type, and this is an IR class symbol. So that, I mean, which is fine. And this is an IR type. So it shouldn't really matter to us. And this is always going to be null. So let's just go ahead and do that. This is the super method. Need to generate SAM equals. So false. And then this is null as well. This might be something, so we need to keep this stuff. That's fine. I don't think there will be a bound receiver though, because that wouldn't happen without bound receiver wouldn't happen without the double colon syntax. Okay, so if SAM supertype is null, else null. So SAM supertype will never be null here for us, and so this is fine. So then basically the supertype is the only supertype that we end up creating. And then it's always going to be a lambda. Let's just assume that's true. Okay, so in here we can do that. I'm not sure if we end up needing this or not. Fake override receiver field. So it's always going to be a Kotlin fun interface. So let's just go ahead and call this true as well. All right, and then SAM supertype is always going to be non-null, but bound receiver might not be. I don't think we're going to have a bound receiver. Function bind receiver, and even then we can only bind extension or dispatch receiver. Okay, so I'm gonna go ahead and say this is null. Hey Christopher, thanks. Hi Uranium. So bound receiver is always gonna be null, which means that this is gonna be null. Create invoke method. So it's a lambda always. So we don't need that. And that means we don't need this variable. And we don't need that. Okay. So bound receiver is always null. SAM supertype's never null, so we don't need any of that. SAM supertype will always be non-null, so it's always going to be this. And we'll use IR built-ins. Okay. And then I'm gonna IR builder generator context. Hopefully that works. And then the SAM super type's never null, so we can get rid of this. Yep. Okay. So it looks like we can get rid of that. Get function reference flags. I guess that's not called. We deleted that. So that we can get rid of. Looks like that too. We'll have to figure out what to do with this. Because I don't think we have access to this. I guess build override isn't used, or is this? Okay. Well, I mean, that's a pretty good reduction here. Okay, and so then fake override receivers is also not used. Which means this isn't used. Looking good. We can get rid of these. Find usages. Oh, not used. Okay, I'm surprised this isn't used. Oh, I see. So I guess that's only for lambdas, because it needs to create the interface type, and we don't need to. So interesting. So this would only happen if bound receiver is not null, I guess. Value arguments count. Yeah, okay. So we can get rid of this as well. So I'll get rid of that. So that's pretty nice. When we do build, oh, I see, we needed to pass that in. So no more SAM super type. And then the superclass actually isn't even saved. So I guess we can do that. And so then at this point, the only issue here is this name mingling thing. Suffix. So I wonder if this isn't needed at all, because maybe after I generate this class, the name mingling will take place afterwards. That is my hope, but we will need to verify that. So and if lambda is always true. Actually, let's just go find usages on this. Okay, that's the only one. So basically, we'll just have to remember to write a test that has an inline class return type and make sure that that works. Sure that this works with an inline class return type. All right, what is it? I guess they're doing this a lot. I don't know. I want to keep it anyway. Get rid of that and this. Thanks, Tutor. Nice seeing you. Uranium asks, is it me or your code font is different? Yeah, the font I use is Dankamano. You want to look it up? It's dank.sh is the website. And then I'll make this private, I guess. I'm just gonna ignore this for the file. Suppress for class. Just because I'm trying to keep somewhat some of the original style from the source here. Okay, so we basically have a very slimmed down version of the function reference builder, somewhat modified, that that should work for our purposes. And so if we go back here, we can basically do the same thing here that they were doing in their lowering, but we want to only do it so basically we're only going to do it if it's like a composable SAM conversion, and everything else we're just going to pass through the original one. So let's just create a little helper to validate that. Is composable SAM conversion. So let's just say fun interface conversion, and then we'll pass it a type operator call. And then I'm just going to replace this with, let's just see. Expression. Okay, and then if it is, then like basically this block will never happen. And then this one will. So we can do this. And let's just say as IR block. Let's just do that. So reference here is going to be this. Yeah, as IR function reference. And then we need to fill out this function reference builder. Which is going to have a lot of stuff here. So the function reference goes first, and then the superclass. So let's go ahead and put that in something here. Val super type operand. So this is an IR type, and then we'll have a superclass, which will be the super type dot class or null. And if it's null here, then something went wrong. So expected non-null class. So then here, super type. Oh, super class goes first. And super type. And then we get our current declaration parent. Trying to remember if we have this. And then our context.ir built-ins. Okay. What's wrong there? So we need to create these, and kind of funny, I thought, so this is an IR element transformer void, and basically the function reference lowering, they used, what they used? IR transformer void with context. And I think we can just go ahead and use this because I don't think that we're using anything from our abstract compose lowering. So let's do that, and it'll be more similar to function reference lowering. So let's see. And that's parameterless, so we don't need that. I'll keep our plugin context. So now I can say current scope dot scope dot scope owner symbol current declaration parent. What's the deal here? Generator context. Oh. Whoops. Do I have a generator context? I thought I did. I see. They have one. Oh, plugin. So context itself should be. I am confused. Generator context. Because here, all that's needed is this plugin context. So that should be all that we need. Oh, I flipped the order. Oh, no, that's fine. That's correct. Oh, I used a generator context, not an IR generator context. Okay. And the rest should be fine. So this function now needs to return when the type operator is a SAM conversion to a function interface that has a single composable abstract method. So type operand expression. So the operator is a type operator, and so we need to verify that it's like a lambda. So argument is IR block, and argument dot is lambda. I thought that would work. What is it? Oh, origin dot is lambda. Okay. Origin dot is lambda. And then type. So I guess there's a classifier, type operating classifier. Functions single. So what does this work on? Superclass. So I guess we can do this and function class equals type dot class or null. So then I can say function class is not null, and function class so it should have a single abstract method. I thought there would be so if it's the same conversion, this should always work. And then here I should say, I should be able to say essentially has composable annotation, which we would have had if we were in our abstract compose lowering, but we're not. Has composable. Okay, so we basically want this. Annotations has annotation. Because this will give us back a single function. Right, simple function symbol. So then we'll say .owner .annotations has annotation. Okay, one concern is that this might not, this might throw like a unbound symbol error or something like that. But I think this is, loosely speaking, what we want here. It's probably enough to get us started. So we can give that a shot. So we don't need any of these. So get rid of those arguments. Get rid of them here. Okay, so at this point, I think we can go and rerun our test and just sort of see what happens. So where was that test? All right. And while that builds, I'm gonna go get some water. Andre says it doesn't throw out unbound symbols anymore. That should be Nightmare of the Past. Is that true? I'm not sure I believe you. I think it's still possible for that to happen. All right, good night, Luke, Tutor. Thanks for joining. Yeah, I'll be right back. I'm just getting some water. All right, we're back. So Andre, I'm pretty sure, I mean, at least I was under the impression that I could still, if I started poking at stuff, like grabbing annotations and symbols on the annotations and then the owners of those symbols and annotations on those and so on and so forth, that some of the symbols could still end up unbound. But maybe I'm wrong. Maybe you know something I don't. All right, so I mean, it looks like it's kind of just doing the same thing. So what I'd like to do is just debug this and then go to our new function interface and see if this code even gets called. Andrew says, no, the compiler team did a great job on fixing that, especially if you're using a provided API for poking random symbols. Do you mean the... So I mean, it's still something that I can get out of by, if I use the IR plugin context and use it to say like reference a class or reference something, then I won't run into unbound symbols. But if I just go and poke at symbols, then I think it'll throw an exception the same way it did before. But I'm only saying this because I basically ran into exactly this in the stable inference stuff that we've been working on. Right. Don't care about that. Yeah, so okay. Yeah, maybe I will report it, but basically I can show you kind of where it was happening, but I was getting into trouble when I was looking at a type, finding the classifier of the type, and then looking at the annotations of that and then looking at the classifier of the annotations and some stuff like that. So it definitely was me sort of moving far away from like the what looks like matters in the tree. Where is this? Oh, still on the front end. Don't care about that. Okay, so here's our SAM conversion. And the argument is lambda. I see. Okay, so that's that. And so then our type is A. Okay. Oh, and the type operand. Yeah, that's A as well. So this should have some declarations. I guess let's just dive in and see what happens here. So, oh, weird. Okay. So what I want to see is if I do this. So that gives me a simple function. And then the owner of that, I want to see, it should have the composable annotation, which it looks like it does. Annotations field, size 1. Yeah. So that should return true. So let's see if we end up, we don't. And where's this? So this is now in the original type lowering. Okay. So we didn't go through that. I wonder why. Annotations. All right, let's try that again. Oh, sorry. Oh, I'm so bad. And of course the sounds aren't working again today. I'm not sure why. I see. So you're saying that you're having some unbound symbol issues? Okay. So for some reason, this is returning false. So what I want to see is this. So this, I guess, is probably what's returning false. No, that's returning true. Okay, so I see. Our argument isn't an IR block. It's a function expression. I see, because the lambda hasn't been lowered yet. That makes some sense. Okay, well that's easy to fix. We basically have, so argument is an IR function expression. And I don't think we, actually, the argument origin is probably still the same, right? Yeah, okay, so that should still be fine. And then argument, I guess we don't really care. We don't really care about the function, but that is going to change what we do here. So this will be an IR function expression. Bookable. So we don't have a function reference anymore. We just have a function. That might make our lives easier. I guess we have to deal with that here now. So invocable, basically I'm going to change that to let's see. So we want to I wonder if we can say that transform this null. And then the result should be a function expression here. And let's just say that's the argument. And now this is going to take a function expression. And let's just hope that that doesn't mess everything up. So I'll copy the source range for the expression. That's fine. Can do the same thing for copy attributes. I'm not sure what we should do for the metadata. We should think about that. Yeah, not sure if there's something we need to do for the metadata, since the function expression will just have a function on it. And maybe it has metadata. But I'm not sure, because I think this needs to be class metadata, not function metadata. So the callee, I think, is just going to be the function. Okay, so we've got everything. There are no errors now, so that might be all we needed to do. We shall see. So that's an even bigger reason, like, for this, basically keeping this class similar to the one in Kotlin. I think it just wasn't possible. And the fact that we aren't going to have a function reference, we'll have a function expression. That's like another reason of the several that we already ran into that it just isn't palatable to do that. So hopefully this will work okay. And it's really not, I mean, it's 150 lines of code, really. It's not a huge deal. So let's see if this ends up working. It might, not sure. Yeah, radon. I think that all of the viewers of the stream will hear the sound, but unfortunately it's not going into my headphones. And it seems like almost random. Sometimes it does, sometimes it doesn't. And I haven't really figured out why yet. So sorry. If someone is like really good with streaming setups and everything and wants to help me, that would be great. Yeah, the sound isn't particularly pleasing, but The whole point of the sound is for me to realize that I'm like streaming the wrong screen or something. Doesn't seem to be a good way to alert me of that otherwise. All right, let's see where we get this time. So great. So this time we made it into the if statement, so that's promising. And hopefully this will work. I'm just gonna hit play here. So the test failed, but I'm not sure with what. Oh, okay, the comparison is different. Sweet, so it looks like it kind of worked. So this test, what did we end up with? Oh no, it does not look like it worked. All right. Sorry for the false sense of success there. So it looks like the result here, we end up creating this class, but the method that we create doesn't have the @composable on it, which that actually kind of makes sense because I'm guessing this code doesn't deal with that. And since this is our code now, we can just make it do that. So that's great. I think this will be an easy fix. We're creating the invoke method, which in this case is this method. And so all we really want to do is we want to make sure that the annotations end up being, I mean, we can use the plus equal, I guess, but this could be super method dot annotations. Oh no, dot owner dot annotations. I wonder if that'll work. I think it will. Proxper asks what language you're using, and this language is Kotlin. So we're actually working on a plugin to the Kotlin compiler and using Kotlin to do it. So I'm guessing that this is going to work. Knock on wood, I guess, but I think that was the only problem. And then after this, it'll just look like a normal method on a class, and we should transform it properly without any of the SAM conversion code that we had in the function body transformer. Okay, cool. So this ended up creating this, which this is actually what we expect, because so this is the SAM object. So this is the thing that implements A. It's got a single method compute, which is now properly getting transformed into a composable compute. And then the body of this the body of this function will end up having an update scope lambda created, a synthetic one. And so that's this. So this class then is the synthetic update scope lambda. and it looks like it's, you know, basically correct. So that looks promising. Now what I want to do is go to the transform test. So this is essentially the same code, but this will show us our transformed code. So I want to see what that shows up as. And so what we should see here is basically this, except the this will be like a start restart group, and this will be a start restart group, and then it'll have like a update scope with some stuff in it, right? And let's see, this is more or less what we see. Okay. Yeah, so this ends up looking basically like an object literal. So my source printer isn't, you know, printing this out as like a pretty lambda syntax, but that's kind of the point, because the pretty lambda syntax is the thing that we're transforming into a less pretty syntax. So like there's not really much we do there. Okay, so we have this compute method. It's properly annotated as composable, and it's got you know, all of this. So we've got all of our skipping logic here, ends up calling this recursively, and then what we end up doing is we create this like receiver temporary, which is then bound to this parameter, which remember, so this is the thing that we couldn't do before, but now we can, because we have this like class that we've created that has this parameter on it. And so that allows us to call compute again on that object. And so that's what we do here. So that is nice. And then this is just sort of what it ends up looking like, because it's basically saying, you know, construct this class here. Is creating a class and saying construct one of them. So that is really cool. Looks like it's all working, and I think we can actually get rid of some stuff in the function body transformer that we added. I don't think we need this anymore, because the only SAM conversions that will still exist when we get here are the ones that we don't care about anyway, that were already being handled properly. And so I think we can basically undo all of the changes that we made here. We don't need the SAM conversion thing. It won't be a lambda anymore when we get to this point. So this code that we had before is basically still correct. And then we move to this like should be restartable thing. Let's go ahead and undo that, and undo this. So where's the change? Okay, what line of code was this on? Oh, I guess this was like way up top. So here, yeah. So, and then we have this should be restartable function, and that should still work properly. So this file now should be unchanged. I'm just gonna, I think it would be nice if the diff that we end up with like basically doesn't change this file at all. So even though these are like unused apparently, I'm just gonna ignore them for now. So so now if I look at the stage changes, composable function body transformer just doesn't show up at all, which is really nice. That's what I want. All right, so we're pretty close actually to finishing this. I'm gonna clean up some of this code. I don't need this anymore. Let's optimize these imports. So let's go to the function reference lowering. No, not that one. Function reference builder. I think we need to figure out if this is something we need to do. So I think what we should look to see is if the generated class file, if the generated class file has metadata on a non-composable SAM conversion but doesn't on the composable one, then basically we're probably missing something here and we should fix it. I'm less worried about this because this class should be anonymous, and so it's a synthetic anonymous class that like it's not going to be used by another module in any way. So I don't think it's too important that the metadata end up on there. That's my hypothesis, but we'll see. So this isn't really necessary comment anymore. And the other thing we want to do is ensure that an inline class return type is also working properly. So yeah, I don't think that's a necessary comment anymore. Yeah, sorry, Elena. The IR name prefix stands for intermediate representation, like Giuseppe said. So the basically in a compiler, what you often end up doing is you transform your code, like the source code, into an intermediate representation, which is similar to like an abstract syntax tree, if you've heard that, but it's got more information than that. And then that intermediate representation, that's kind of a tree structure that you're able to manipulate and perform what's called like lowerings, which will kind of turn the source code into simpler and simpler constructs that mean the same thing. And so the IR like part of the compiler is sort of what we're working with right now. And so that's why a lot of these classes have that. Baraz asks which using platform. I'm not entirely sure what you're asking, but right now I'm writing code for the Jetpack Compose compiler plugin, which is a plugin for the Kotlin compiler, which is a language to write Android apps in. All right, so that function looks pretty reasonable. No problem, Elena. So I think let's write a few of these other tests here. One of the tests that I want to write is for the composable function interface that returns an inline class. I want to make sure that that results in a mangled name, I believe. So let's give that a shot. Let's say composable fun interface with inline return type. And then I'll say inline class. Let's just say color, val, color, int. Let's just say value. And so that's an inline class. And if I want it to return an inline int, then I can do something like this. Value int, let's just say value, or it actually, so all that's needed here. Okay. And let's see what that ends up looking like. So actually first what I'm gonna do is I'm gonna look at the non-composable version of this and then compare it to that. So I'll run this first. All right. So the result of this was the following. So, the inline class is going to generate a bunch of synthetic methods, which is expected. And then the interface has this mangled name method on it. And so this is our synthetic SAM object. Interesting. So the problem here, so it's a good thing that we tested this, right? Because it looks like it it sort of double adds this extension. So we don't want that. Oh, although, well, okay, so there's, yeah, it's weird. There's this one. Oh, but maybe, so wait a minute. So this is the non-composable portion. So like we're not doing anything here. This is just what Kotlin produces. So that kind of surprises me actually that it does this. There's a bridge compute II method, but then this one, why? How strange. I want to kind of see. So I want to dump this. So I just want to see what it's doing. Because I mean, whatever it's doing, I don't think it's my fault. I think this is just how the transform works. But that almost looks like a bug. So let's go ahead and run that. Okay, so here's the code that gets produced. And the class I care about is this one. So let's look at that one. Let's go over here, put it in here. Okay, so this is the one that that has like the body. And then what does the bridge one do? I see, so this one calls the internal one. I mean, that's pretty surprising me. I don't know why it would do that. Very confused. But I mean, it does look like it would function properly because the synthetic method's there. So this does properly implement A. So I guess I'll just assume that it's working properly. And we'll go ahead and look at what the composable variant will do. So if I just make this composable, then what does that do? So I want to change this to be without the composable. So theoretically, since this returns a value, we shouldn't, because it returns a value, we shouldn't see any update scope lambda that we synthesized. So the resulting code should actually be extremely similar, or the resulting public signature, except this should just have some, these methods should have some additional you know, parameters like the changed and composable and stuff like that. Okay. Interesting. So, that's weird. What we end up with, it actually looks more correct to me than what the Kotlin compiler is doing. So if you look, the class that we end up generating, it only has this this compute method with the single hash on it, which is the only one that we need to match. And so there's no synthetic bridge method. And both of these have the correct signature. So I don't know. I kind of feel pretty good about what ours is doing versus what theirs is doing. Is that stupid of me? It just seems more correct. If I disable the compose transform, does it still produce double suffix? Let me see if, I'm not sure how easy it is for me to check. Like, I guess here's what I'll do. All of the generator extension just return, like so. So we'll just comment this out. And then if I just test this one, then that might work. Yeah, that's what I'm doing. So see if it produces the same thing. These tests are taking a lot longer to run. I think my computer's slowing down. Yeah, so Andre, it looks like it produced the exact same code. I think the real question is, does the non-IR backend produce the same code? Like, I wonder if this is an IR bug. I'll go ahead and I'll like flag this to someone on the compiler team and just let them decide if it's a bug or not. It looks like a bug to me. So let's go back and comment that out. So I think we're doing the pretty much the right thing for that lowering. And what was the other thing that we wanted to check? Oh, we wanted to look at the metadata. Radon says, so Compose beta next month. I don't know, it could be any time between now and a year and 2 months from now. All right. So I wanted to look at the metadata. To do that, I guess I am going to I'm just gonna dump some of these classes here. So for instance, oh, this is the transform test. Where's the other test? There we go. So what I want to do is dump this here. And then basically what I'll check is to see if there's metadata on this synthetic class and not on our class. Then I guess that's probably a problem. I'll have to figure out if there's metadata that we can use. Although, I mean, they might just put metadata on every class, but it's a synthetic one, so I'm not sure. All right, now I'll get the metadata for this one. I mean, it does look like they put metadata on it, but I think maybe every class has that. I'm not Not sure how important it is. All right. This class is what we want. I guess it still puts the metadata annotation, but I guess it's not as filled as the other one. So basically, if you look, these are the two metadata variants that we end up with. This is the composable one, and this is the other one. So it's missing some stuff here. I just don't know if it's important, but I mean, one thing we can do at least is let's just set a breakpoint where we would do that and like just see if there's any like metadata available to us that would make sense. So we're in here now. So this is where they used to put metadata, and it's for although, I mean, a function reference, its symbol owner might be a function metadata, so maybe it does make sense. Let's just see. I don't understand the metadata system very well. Hey Gabriel, how's it going? Okay, so here we are. And I wonder, so if we look at IR function expression, we've got a function, and it's got metadata. It's function-based metadata. And then, yeah, owner. So, and is it different? Oh, all the, you know what? Can I assign? Maybe the type of metadata doesn't matter. So this as our class. Metadata equals function. Interesting. Okay, so I can do that. I thought that the type was different, but I think maybe it's like a sealed class or something. Like what is this? I see. Metadata source is just an interface, and these are 4 implementations of it. Okay. Well, so let's see what that produces if we end up doing that. Ah, man, when my computer starts getting overloaded like this, it's frustrating how long it takes for these tests to run. I mean, normally if I run this on my machine, you know, it even with a rebuild of the compiler plugin, it still only takes like 15 seconds or something. I don't know. It's definitely not this long. Okay, so the metadata for this function ends up being this, which looks really close to what we were expecting. Might even be identical. So let's see. So now these lines are basically identical. So that looks good to me. I think that's the right thing for us to do. And we can remove these 2 to-dos here. All right, I feel good about that. Let's remove these dump classes parameters. All right, so this is pretty close to like kind of shipping, I guess. What I want to do is just see kind of some of the changes that we ended up making. Because I don't remember all of this. But I think this looks reasonable, although this formatting is really weird. Kick off at KT lint. Okay, so we added this, which sort of handles this case where we have a lambda that's getting converted into a composable method. And then a similar thing here. So expected composable. Okay. Programmer, I use a font called Dankmono. You can find it here. Okay. So I kind of forget why this wasn't used before. Check type. Oh, I see. Because it might be a SAM type. So we don't need this. And then what else did we change? We made that internal. Does that make sense? Not using this anymore. So cleaning up some unused imports. All right, and then there's the lambda memoization, which we made some changes to. So here, not wrap composable function interface SAM conversions. So I don't think that we need this anymore. Because we're doing the SAM conversion before this transform. So I think we can basically undo the changes in this file. Okay. Oh, sorry. I'm just going through and cleaning up some of the changes that we don't need. So function reference builder we want. You know, the change to the source printer doesn't really matter to us anymore. Well, we should include that anyway, just because for, you know, completeness. So this seems right. We just added this. It's right before the lambda memoization. And here we are adding some checking for the SAM conversion for that. extension point. So that makes sense. Alright, so I ran lint on the command line, and there's just like a few things here that I need to fix up. So function reference builder. '83. That can be like that. 55. It's a needless blank line. All right. We removed the unused import in the lambda memoization. And the param signature test. Which has an unexpected blank line here. That. Okay, so it seems upset about this, which seems like a valid thing to be upset about. Which that works just fine. And I think this will go over the line limit, so that. And then it looks like it doesn't like this syntax either, which I don't know why it got formatted like that. I don't remember doing that. And that should be fine. Check for. All right. I think that's pretty good. I'm gonna run kt-lint one more time and ensure that it's working or passing. And then I think we'll put this up on Garrett. Okay, so compose type resolution. Looks like there's still some complaint here. Oh, from this one. Makes sense. And then that should be good. So now what I'm gonna do. So I'll put this change up. I'm gonna give it like the same change ID as before, so it shows up on the same CL. And trying to see if I have a bug for this. Looks like I do. Okay. So I'll say bug : that. And then from here I can, oh, I need to log in. I don't know if anything weird shows up from that, so give me 1 second. All right. And now I can push it. Okay, so now this CL, which had the change before, just got updated, and this is what the CL looks like at the moment. Let's just do a quick glance at everything. All right. This looks good. So I'm gonna have it run pre-submit checks, and we'll see. Hopefully that passes. And if it does, then we'll ship it. That is pretty much all I got for that. So that probably is a good time for us to end this stream. And I hope that was interesting to all of you. But let's see, next stream will be on Friday. I might end up streaming something tomorrow, I'm not sure. But if I don't, Friday I'll probably be working on some compiler stuff. Not exactly sure what that'll be yet. It might be going back to the stable inference work that we've been doing before. I still haven't shipped that. There's a memory leak that I'm kind of fighting right now, and so I need to find the memory leak. And not sure if I'll have that done by Friday or not, but if not, maybe we'll do a bit of that. Anyway, I will see you all then, hopefully, and have a good one. Cheers.